Good morning to all dear students. Today morning we are going to talk about machine learning. In this class we are going to see introduction part of that machine learning. Before entering into that topic of that machine learning, let we have to understand what is that kind of traditional learning and then machine kind of that learning. So in that traditional kind of programming, let we have to feed that is the data into that program. So that means data and the program is run on a computer and to produce that output. In case if I am running that program at that task pan or in that control panel, it will ask for the data. So when I am feeding that is the data, then program produces its output. So this is the term is called that is the data programming. So let I have to feed that data and program to get that is the output. So this is the kind of that traditional programming. But in case of that machine learning, so what we have to do is I have to feed that is the data and then I have to say that is what is the expect that output and then it generates that program. So this is the primary difference between the traditional programming and machine learning. So in that machine learning, the data and output is run on the computer to create a program. This program can be used in traditional programming. So this is main differences between that machine learning and then traditional programming. And again, I am saying in that traditional programming, we have to feed that data and program and the system generates its output. But in machine learning, that I have to feed the data and I have to feed that is my output and then it generates that program according to the data and to the output. So this is the primary difference and basic part of introduction in between traditional programming and then some machine learning. And let me have to see what are all the key elements of that machine learning. In that every machine learning algorithm, so there is the three kind of key parameters. So number one it's called that is the representation, and number two is called that is the evaluation, number three is called that is the optimization. In that representation, it means we have to be represent that knowledge or the data sets. We may say that is an examples the decision trees, set of rules, instances, and graphical models, neural networks, and support vector machines, and model ensembles, and other things. So these are all the kind of the representation. That means in what parameter I am going to analyze that data. So this is the term is called that is the representation. This is important key role when we are talking about that is the machine learning. And the number two is called that is that evaluation. In that evaluation, let me have to evaluate that candidate programs. So how I am going to evaluate that represented data. So we may say that is the prediction or squared error and the likelihood, posterior probability, cost margin, entropy, pullback labor, and then these are all the parameters that we have to make that evaluation with the data. And then third one, it's called that is that optimization. So in that optimization, let me have to do that combinatorial optimization or convex optimization or constraint optimization. So you may ask, so what is the purpose of that optimization? So we are feeding that data and we are applying that representation and we are applying that is the evaluation. But when we have to come out as an predicted output, we need that is the optimization. That means we need that outcome with the relevancy. So that we have to go for the optimization. So the main key elements of that machine learning are a representation, evaluation, and finally optimization. And then next topic that we have to see what are all the kinds of that learning. So there are three types of that machine learning in that entire region. So the three types are number one, that is the supervised learning, and number two is called that unsupervised learning, number three is called that semi-supervised learning, and number four is called that is the reinforcement learning. That we have to see that is the one by one. So what is what? And in supervised learning and also it's called that is the inductive learning. So here we are having that to train the data includes that desired outputs. Say in case I am having that is the one data sets, and I am training the data with the desired outputs. So I can define, so this is the output from this data set. Such a kind of that learning is called that is the supervised learning, and another one name for that supervised learning is called that inductive learning. And then number 2 is called that is the unsupervised learning. In that unsupervised learning, the training data does not include that is the desired outputs. I'm just feeding the data. So from the data, let I have to work with the, some of the key elements. It may be in the form of the clustering, or let we have to define the predictive things. So in that scenario, it seems to be a little bit hard, but with that appropriate algorithm that we have to come to that predictive outcome from that unsupervised learning too. And then number 3 is called that is the semi-supervised learning. In that semi-supervised learning, we are training the data sets with that few desired outputs. So let I have to specify, it may be, so these are all that outputs. In case if I am training the data sets, such a learning method, it's called that is the semi-supervised learning. And then number 4, it's called that is the reinforcement learning. In the reinforcement learning, we are defining artificial intelligence kind of the things, and with ambiguous types of that learning. In that reinforcement learning, the system can able to receive the data from that real time. It may be that already defined, or it may not be already defined, but whatever it may be, the system has to perform according to that input, and it has to be produced that predicted output. So such a learning is called that reinforcement learning. So total 4 types of that learning methods in that machine learning. Number 1, it's called that is supervised learning, and number 2 is called that is unsupervised learning, and number 3 is called that is the semi-supervised learning, and last one it's called that is reinforcement learning. And then so now let we have to see that is the little bit depth in that supervised learning. So in that supervised learning, there is the 2 things that we have to do, and another one name of that supervised learning is called that is the inductive learning. So in that inductive learning, so we have to be apply that 2 things. That is number 1 is called, in that learning data set, we have to remove that uncertainty. That means we have to remove that uncertain data from that data set. So for that I have to apply that appropriate hypothesis to remove that uncertainty from the data set. And that's the second one. So the learning is guessing a good and small hypothesis class. In case in machine learning, so that we have to be go for that guessing. So when we have to be go for that is the guessing, we have to be give that a certain boundary. So within that boundary, the data set may be guessed and then produce that respective output. So in that case, it has to be go for that trial and error process. So all these things that has to be applied into that inductive learning. So if you knew the domain with the certainty, and you do not need that is the learning, but we are not guessing in that dark. So this is the phenomena what we have to be used in that inductive learning. And then what are all that framework what we have to be studying in that inductive learning. So first thing, the terminology we are using in that machine learning, so training and example. So this is the very primary parameter. In case a sample from the text including its output from that target function. So this is called that training example. And the number 2 is called that is the target function. And we have to be make that mapping for that f for that and that x in the term of that f of x. And number 3, we have to be apply that hypothesis. In that hypothesis, we have to be apply the approximation of that f with a candidate function. And then number 4, we have to be defined that is the concept. This concept define the Boolean target function with the positive examples and that's a negative examples. So what are all that position it's having that positive, and what are all the positions is having that negative. And the next one it's called that is that classifier, and then we have to be put that is appropriate learning program to do that is the classification among the derived data set. And then next one it's called that is the learner, and for that classifier we have to be give that is the learning mechanism, that is process that creates that is the classifier. And then hypothesis space, so this is the set of the possible approximation of f that the algorithm can create. And the next one is called that is the version space, the subset of the hypothesis space that is consistent with the observed data is called that is the version space. So these are all the frameworks that we have to be included in that say inductive learning.